Right. Good morning, everyone. So this is the second video of our lesson series, Quadratic Equations. So in the last video, we have studied about the computing the square method. Then using that, we have drawn some curves. So this is the point where we have stopped the first lesson. Right. Now we have three quadratic equations. In the last video, we have used the computing square method to find the factors of these three equations. Now I'm going to write down those equations and I'm going to draw the function of these three functions, right? So first graph, fx equal to x square plus 2x plus 1. So if I draw the graph, this is a parabola, parabolic shape, right? This is a parabolic shape graph. Here, this is the y-axis and x-axis. Now, this is the graph fx equal to x square plus 2x plus 1. So if you factorize this, we will get the function fx equal to x plus 1 square. This is the function we will get, right? Now, here, if you substitute x equal to 0, when x equal to 0, you will get the y-intercept value. When x equal to 0, you will get the y-intercept value. So here, when x equal to 0, y equal to 1. This is the y-intercept value. When y equal to 0, you will get the x-intercept value, that is minus 1. Right? That is minus 1. Okay. Same way, we can draw the graph of the next function, x square plus 2x plus 2. Now we can draw the graph. Here, we have factorized this using the completing square method, but we remember that there are no factors for this function. So the simplified function is x plus 1 square plus 1. This is the simplified function that we have get. Now, if you draw this graph, this is the graph we will get. Yx. Now this is the graph. Right? So, right, this is a parabolic function. Now, here also, when if you put x equal to 0, when x equal to 0, if you put 0 here, you will get the, if you put 0 here, you will get the value of the y-intercept. That means the intersection point of the graph with the y-axis, right? That is y-intercept. So that is equal to plus 2, right? When y equal to 0, right? When y equal to 0, there are no intercepting values because there are no intersection points with the x-axis of this graph, right? Okay. Now, here this is the minimum point. This one is 1, here 0, and this is minus. Okay. Now we can draw the graph of the second one, the third function. Here also we can simplify this function using the completing square method. Then the simplified function is x plus 1 square minus 3. Right. Now we can draw the graph of this function too. Right. So here minus 4. Right. Here we will get two factors. Therefore, we will have two intersection points. So this is the graph. This is the parabola, x-axis, and here we have y-axis, x-axis. Right. So when right now we can separate this into two factors. If you separate this into two factors, fx equal to, right, fx equal to x minus 1 into x plus 3, right? So when if you when x equal to 0, if you put x equal to 0, you will get the intersection point of the y-axis, right? When x equal to 0, you will get the intersection point of the y-axis. So when x equal to 0, this one will become minus 3. So here intersection point is minus, right? Here it is minus 3. when y equal to 0, when y equal to 0, you will get the intersection point of the x-axis. Here there are two factors. When y equal to 0, there are two factors. That means there are two answers, x equal to 1 and x equal to -3. Right? So here -3 and here +1. Right? So I will draw this graph again. Here we have -3, here +1. Those are the two intersection points of this graph. Right. Now, if you look at these three graphs, this first graph, if you simplify this function, you will get a complete square. Right? If you simplify this function, you will get a complete square. Right? Then, and also if you draw this graph, there is only one single point that touch the x-axis. Right? So this function will touch the x-axis only once. And the function is positive. All the values in this function is positive. In the positive side, only one value will become 0 when x equal to -1. Right? Only one value will become 0, other values are positive. Here, all the values of this graph is positive. Right? The whole graph is in the positive sort. Right? So if you consider this graph, there are two intersection points in the x-axis. Right? The function will intersect x-axis at 2 points. Here only in 1 point. In here there are no intersection points. Right. So that means here we have one solution, one root. Here we have two solutions, two roots, and here we have no solutions. If the graph intersect with in 1 point, that means there is one solution or one root. If the graph intersects at 2 points, that means there are two solutions or two roots. If the graph doesn't intersect at all, then that means there are no solutions or no real roots. Right? So those are the types of quadratic functions we will get in this lesson. Right? Okay. Now write down a small note. Write down this note. Write down the main three types of quadratic functions. Write down the main three types of quadratic functions. Number one, first one. Write down quadratic functions. First one, number one, quadratic functions which touch the x-axis. Quadratic functions which touch the x-axis. That means these types of functions. Right? That means these types of functions. Right? In front of that line, write down in brackets one solution or one root. Right. And next one, write down number two, quadratic functions which exist above the x-axis. Quadratic functions which exist above the x-axis. Right. That means these types of functions. Right. In front of that line, inside the brackets, write down no solutions. So here we have no solutions. Right. Number three, write down quadratic functions which intersect the x-axis. Quadratic functions which intersects the x-axis. Right. In front of that line, write down two solutions. That means these types of functions. There are two solutions. Okay. Right. Now, same way, I will consider another three functions. Right. So these three functions are a little bit different than these functions we have drawn. Right. Okay. Now look at this. I'm going to draw another three functions. I'm going to use these three functions. Right. Now, first one is fx equal to minus x square minus 2x, x square minus 2x minus 1. This is the first type, first function I am going to use. So here we can separate minus sign. We can separate minus sign. Then we have x square plus 2x plus 1. Right? X square plus 2x plus 1. Now we can simplify this using the completing square method. Right? We can simplify this using completing square method. So x square, we can take x without the square, then x. Right? Then we can take the plus sign here, then divide the coefficient of x. Divide the coefficient of x by 2, then take it here. Then take the square of whole thing minus the square of this constant. Minus the square of this constant minus 1 plus 1. Right? Now here minus 1 and plus 1 will cancel. So answer is minus x plus 1 square fx. Right? So if you look at this, this is the negative function of the previous function we have drawn. Right? The second function. Now look at this second function, fx equal to minus x square minus x minus 1. Right? This is the second function. Now I'm going to separate minus sign, x square plus x plus 1. Right? Now we can use the completing square method. Take the x value, take the x without square, x. Take the positive sign, divide the coefficient of x. Here coefficient of x is plus 1. Now divide it by 2, then half. Square of the whole thing minus square of this constant. Square of this constant 1 over 4 plus 1. Right. Now if you simplify this, we will get fx equal to minus x plus half square plus 3 over. Right. Next I will get another function, fx equal to minus x square minus 7x minus x square plus 7x minus 2. Minus x square plus 7x minus 2. Right. Now here, if you separate negative side, we will get x square minus 7x plus 2. X square minus 7x plus 2. Now again, here also we can use the completing square method. Here we have x square. Take the x without square. Take the x without square. Here we have x. If there is negative sign, take the negative sign here. If there is positive sign, take the positive sign here. Divide the coefficient of x by 2, 7 over 2. Take the square of the whole thing. Then minus square of this constant. That means 49 over 4. Right? 49 over 4 plus the remaining part 12. Remaining part 12. Right. Now simplify this. Minus x minus 7 over 2 whole thing square minus 49 over 4. Here we have 12 over 1. That means if you multiply both numerator and denominator by 4, we will get 48 over 4. Now simplify this function. Now we will get this is equal to minus x minus 7 over 2 whole thing square minus 49 plus 48. That means minus 1 over 4. Right? So minus 1 over 4 we can write down as half square of half. Right? Now here we have difference of 2 squares. Here we have difference of 2 squares. So we can separate into factors. Right? We can separate this into factors. So before that, write down here. Here write down this is a complete square. Write down complete square. This is a complete square. Right? Here write down. Here we have sum of 2 squares. This is a square plus we can write down 3 over 4 as a square. That means root 2 over 2. Right? So this is a sum of 2 squares. Sum of 2 squares. Right. Here we have difference of 2 squares. Write down difference of 2 squares. Right. Okay. Now I'm going to multiply this by minus 1. Fx equal to minus x plus 1 x plus half square plus minus 3 over 4. Here we can separate into factors by difference of two squares. So we can write x minus 7 over 2 minus half into next factor x minus 7 over 2 plus half. Then if you simplify, we will get minus x plus 3 into x plus 4. Right. So these are the two factors. Right. Now here also we have two factors. If you write down this as fx equal to minus x plus 1 into x plus 1, we can write down this as x plus 1 into x plus 1. So here we have two equal factors. Here we have two different factors, and here we don't have any factors. Right. Here write down a point. Here under this one write down has two equal factors. Has two equal factors. Here write down a point. Cannot factorize further. Cannot factorize further. Right. In here, write down a point. Here write down. Write down can be separated into two factors. Can be separated into two factors. Right. Okay. Now I am going to draw the graphs of these three functions. Right. I am going to draw the graphs of these three functions. First one, fx equal to minus x square minus 2x minus 1. Right. Okay. Now look at this. Right. Now I'm going to draw the graphs of these three functions. So first function, we had three equal factors. Right. We had three equal factors. If you draw the graph, this is x-axis. Right. This is y-axis. So graph will look like this. Y-axis 0. Right. So our previous function, we can write down that function as fx equal to minus x plus 1 square. This is the function. This is the function. This function we can simplify into this one. Right. So when y equal to 0, when y equal to 0, this value will become, when y equal to 0, x will equal, x become minus 1. Right. So here we have minus. Okay. Then when x equal to 0, when x equal to 0, y will become 0 plus 1 square. Y will become, y also will become minus. Here we have minus. Right. So this is the graph of the first function. This is the graph of the first function. Right. So next one. Now look at this. Next function. If you draw the graph, this is how the graph appears. Right. This is y-axis. Here we have x-axis. Right. Now here also, we can find the y-intercept value. So when x equal to 0, when x equal to 0, right? Here when x equal to 0, y will become minus 1, right? And also we can simplify this function like this. Y equal to minus x plus half square minus 3 over 4. So when x equal to 0, y value is minus 1. When y equal to 0, when y equal to 0, if you make this one 0, x plus half square minus 3 over 4. Then we can take this term to the other side. Then x plus half square equal to minus 3 over 4. So you cannot get the square root of a minus value, right? Therefore, there are no real values for this function. That means there are no real roots for this function. You cannot take the square root of a negative value. We will talk more about these types of numbers in the complex numbers lesson, right? But for now, we can't take the square root. Therefore, there are no intersection points in this graph. So here we can find the minimum point. Minimum point will become, here we have minus 3/4, and here we have minus half, right? So same way we can draw the graph of the next function. Same way we can draw the graph of the next function. Now look at this. In here, if you draw the graph, there are two intersection points. There are two intersection points to this graph. Right. So here x value, and here we have y-axis. Right. Now, right. So we can write down this function as fx equal to minus x plus 3 into x plus 4. Right. So when y equal to 0, these two factors will be equal to 0. That means x equal to minus 3, x equal to minus 4. So these are the two intersection points, x equal to minus 3 and x equal to minus 4. Minus 3, minus 4. There are two intersection points, right? So if you consider these three graphs, these are the shapes of these three graphs. So if you consider the previous three graphs, the shapes are a little bit different. So in the previous graph, this was the shape. In the previous graph, there is a minimum point in the graph. But in these three graphs, there is a maximum point in the graph, right? That is the main difference. That is the main difference of these three graphs. So if you consider about the coefficient of the x square term, here the coefficient of the x square term is a negative value, right? Here the coefficient of x square term is negative value compared to the previous three graphs. That is the only difference in the equation. So in the previous three graphs, there is a positive coefficient for the x square value. Now here we have a negative coefficient for the x square value. That is the main difference. That means if there is a negative value, negative coefficient for the x square term, the graph have a maximum point. So here we have a maximum point. In the previous three graphs, we had the minimum point. Right. So here under this graph, write down a point. Under this graph, write down a point. The function will touch the x-axis. Write down, the function will touch the x-axis. Right. The function will touch the x-axis. Here, write down next point. Next point, write down in red color. There is only one solution. There is only one solution. Inside the brackets, write down one root. One solution, one root. Right. Under the next graph, write down a point. Write down the function will exist below the x-axis. The function will exist below the x-axis. Below the x-axis. Write down the second point. Second point in red color. Write down no solutions. No solutions. Inside the brackets, write down no real roots. No real roots. Right. Okay. Now under the third function, write down a point. The function will intersect the x-axis. The function will intersect the x-axis. Write down second point in red color. Has two different solutions. Has two different solutions. Inside the brackets, write down roots. Two different solutions. Write down roots. Right. Okay. Right. So now we know that according to the sign of the coefficient of the x square term, sign of the coefficient of the x square term, there are two shapes for the quadratic function, right? There are two shapes for the quadratic function. Now look at this. I'm going to write down a small summary of the theory part we have done, right? So here we have a, I'm going to write the standard notation for the quadratic function. Fx equal to ax square plus bx plus c, right? Ax square plus bx plus c. Here a comma b comma c are real numbers, right? Are real numbers, and a is not equal to 0, right? So this is the standard format of a quadratic equation, ax square plus bx plus c, right? Here we know that when a is greater than 0, write down first one, when a, simple a is greater than 0. Simple a means the coefficient of x square term. Greater than 0 means if x square, coefficient of x square term is positive, we know that we have a minimum sign, right? Write down has a minimum. Has a minimum, right? So so there are three ways that a minimum can exist. There are three ways that a minimum can exist, right? So look at this one. This is the x-axis, right? So the minimum graph can be like this, or the minimum graph can be like this, can touch the x-axis or can intersect the x-axis. So these three graphs have a minimum point, right? This graph is above the x-axis, this graph is touching the x-axis, and this graph is intersecting the x-axis, right? Okay. Second point, write down when a is less than 0. When a is less than 0, right? Then has a maximum. Has a maximum. Right? If less than 0 has a maximum. Right. There are three ways that the maximum can exist. So this maximum can be like this, or maximum can be like this, or maximum can intersect the x-axis. Right. This graph can be below the x-axis or can touch the x-axis or can intersect the x-axis. Right. So these are the two ways that the graph can exist. When the coefficient is greater than 0, it is a minimum point. When coefficient is less than 0, it is a maximum point, right? Now, you know basic theory part about the quadratic equations, but there are some more theory parts. Before going to those theories, let's do some simple question. Right. So write down a very small question. Before going to the next theory part, we will do a small question. Right. Write down. Find the maximum point. Write down. This is a very small question. Write down before going to the next theory part. Right. Write down. Find the maximum point of the function. Find the maximum point of the function fx equal to minus x square plus 7x minus 2. Find the maximum point of the function fx equal to minus x square plus fx minus 2. Right. Now, to find the maximum point, so how do you know there is a maximum point or minimum point? If you look at this graph, if you look at this function, the coefficient of x square term is negative. Coefficient of x square term is negative. That means this graph has a maximum point, right? This graph has a maximum point. So now we can find the maximum point. We can use the computing square method, right? Write down fx equal to, we can separate the negative value, negative side, minus brackets x square. Here we have minus 7x plus 12, right? Now use the completing square method. Right? Take the x square term without the square. Then take the negative sign here. Divide the coefficient of x by 2. Then take the square of the whole thing. Then a negative, take this, write the square of this constant 49/4. Right? The remaining part 12/1. Right? Then fx equal to minus, here we have x minus 7/2 whole thing square minus 49/4. Multiply both numerator and denominator by 4. Then we have 48/4. Right? Now we can simplify this. Fx equal to minus x minus 7/2 square minus 1/4. Minus 1/4. Right. Now look at this. Now this one we can write down fx equal to minus x minus 7/2 square minus 1/4 we can write down as half to the power 2. Now we have difference of two squares. Now we can separate this into two factors. Fx equal to minus first factor x minus 7/2 minus half. Second factor x minus 7/2 plus half. Right? Okay. Now we can write down the factors. Fx equal to minus here x minus 4 into x minus 3. So these are the three factors. These are the three factors. Right. So now look at this. We have separated this into two factors. So when x equal to 0, we can find the y-intercept value from this. X equal to 0. Here fx equal to minus x equal to 0 minus 4 minus 3. Then y equal to minus 2. When x equal to 0, y equal to minus 12. So y-intercept value is 0, comma minus 2. This is the y-intercept value. Right? Okay. Same way, we can find the x-intercept value or the intersection point of the x-axis. Right? When y equal to 0, this fx will become 0 minus x minus 4, x minus 3. Right? Then these two factors separately will equal to 0. Then x equal to 4, comma x equal to 3. Right? Now using these details, you can draw the graph of the function. Right? So I'm going to draw the graph now. Here we have, now this is the graph. There are two intersection points. And this is the y-axis. X-axis. Right? Now we know the y-intercept value. We have found the y-intercept value as 9 minus 12. 0. And there are two x-intercept values, 3, here 4. Right? Now I'm going to find the maximum point here. Here we have maximum point. I'm going to find the value of the maximum point. The method of finding that. Minus x minus 7/2 square minus 1/4. So this is the simplified function of our function. We have simplified up to this using this completing square method. Right? So we know that when this part becomes 0, x minus 7/2 square, if this will become 0, right, then that is the maximum value that this graph can reach. Right? So if you write down a value here, so if you make this one 0, then x will become 7/2, right? If this part is 0, right? So if you write down a value other than 7/2, there will be always a positive value here. There is always a positive value here. So the total value is always less than this value, right? So you will get the maximum value when this part is 0. Other than that, you will always get a lesser value. So when this part is 0, x equal to 7/2, that means we can find the y value. Then y equal, if you plug 7/2 here, this is 0, then y equals 1/2. So this is the maximum point. Here we have x value 7/2, y value 1/2. That is the maximum value, right? Okay, right. So then